the first part of this presentation, which is dedicated to research impact on society. That is quite a large topic, so I'm just introducing it. Basically, we are going to talk about relationship between science and society, what open science changes in a relationship between science and some other parts of society, and we talk eventually about citizen science. Okay, and my colleague Kristell will focus on assessing research impact, so mainly on bibliometrics indicators. Okay, so the impact of research, of scientific research on society is quite a large question. It's also a difficult question since we are talking here about sociological aspects, about economics, about also the big cultural changes in society. So it's very, very large. There are various approaches to it. We can study it as a researcher in social science, for instance. But it also describes a way to talk about science, a way to having certain types of certain ways of thinking about the way to present science to society, especially in specific disciplines like medical studies or environmental studies or innovation, engineer science. So there are many aspects of this relation between science and society. At least we can say that there is a consensus about its role. This consensus says that in modern society, science has a real leading role in shaping society, much different than what it was in maybe 3 centuries ago. And a few numbers before. In France, for instance, what we spend in research is 50 billion euros. So 2.2% of the general gross domestic product. And in the European Union budget, so I'm not talking here about the budget of the countries of the European Union, but about the budget of the Union in general, as a single institution. It's 8% of its budget that is dedicated to funding research. So still, we can say that research is essential to society. So we can start with this. Question. We can start generally in the 17th century with a reference to the New Atlantis, a piece by Francis Bacon, who was a philosopher and a scientist, British philosopher and scientist. There is this very famous idea of Solomon's house. That is in the New Atlantis is a utopia, and Solomon's house is a mythical institution in which some scientists decide about the way they are going to do research and the way they are going to govern society according to their findings. So there is here a citation. We have 3 that bend themselves looking into the experiments of their fellows. So who evaluate the experiments, the research work, and cast about how to draw out of them things of use and practice for man's life and knowledge. So who try to evaluate what can be done for society, for government, from the findings of the other research teams. So it's current to say that in this image of Solomon's house, there is the first it's the first time that someone says that science could almost replace religion in driving society. And to go a bit quicker, the real change in our societies occur in the 19th century. I guess you already know that. So with the major breakthroughs in science, especially natural science, but also social science. And it's also the century when some knowledge about mostly about physics and chemistry changed the...
Et il nous laisse le premier étage entier plus quelques tables à l'extérieur.
Sorry. And yeah, and eventually it really changed the societies through first social organization by instituting industrial society, and also change the belief with a severe competition to religion, with some new knowledge, like for instance the theory of evolution. And the second big gap, we can notice a second big change after World War II, when science became a huge post of funding, especially in the United States. So with this idea, of course, that after the war, after the atomic bomb, science was a source for power, for political power, for geopolitical power. And an interesting case, if you want to go further later, is the creation of the internet. So I call it a meta-innovation, because the internet also changed the way we do research and the way research relates to society, relates to everyone. And indeed, there were several interesting ideas at the origin of the internet, even a bit before the first technical achievements. There was the engineer Vannevar Bush, who played a very important part in this big change in science in the United States after the war, who had this theory about the MEMX, was a kind of a prototype of the internet that would accelerate science and accelerate its diffusion in society, and would eventually prevent the rise, a new rise of fascism, and very interesting theories about the circulation of ideas and knowledge. Also, someone else who actually worked on the first internet, that was called ARPANET, who had this theory that computers would make every human a scientist and allow communication and collaboration everywhere throughout the world. So there are very interesting theories about of course, about science, about the relation between science and people, just before the creation of the internet. So the internet was at first the ARPANET, as you can see on the picture on the right. And basically it was a very small network between 4 computers at the beginning. And it was a scientific project led by the American Army. It eventually became the internet in several steps further, also with the creation of the web in 1989. Another interesting point with the internet is that it became a model for innovation. So I'm pretty sure that all of you know that science nowadays is always related to innovation, meaning a way to make it profitable. And I guess we can say that the internet is kind of a model for this vision of science, since it started as at once a theory about many theories about communication with university. It started with university scholar research, and it became something first very efficient, and second also profitable. If we think that after 2000 it became a real market that really changed the global economy. So this is another aspect of the relations between science and society, is the relation between science and economy. So this really changed during the 1980s. In US universities, there was the Bayh-Dole Act that allowed them to own and sell patents, so to change some scientific knowledge into a profitable commodity, in a sense. Then there is also, and that is more our topic with open science, the rise of big scientific publisher in the 60s and 70s. That leads us to the current situation with very big publisher that own most of the important journals to disseminate science. And eventually it became a policy also in Europe, in the European Union, with the Lisbon strategy in 2000, with this idea of knowledge-based economy that make innovation as the center, as the motor for growth, for economic growth. So this is another very important aspect of the relation between science and society. I guess all of you noticed that in the last years. And at the same time, that is more related to open science, there is kind of a movement that claims science as a common good. So it's, to me, we can say that it started with the free software movement. So to make it quick, working about software was at first in the 60s, still in the 70s, was something very, very free. That open source software was normal at this time, since it was still a work for professionals. That were improving software in several places in the world, and the codes were, the source codes were circulating to improve this the innovations. And during the 1980s, there were the first big commercial software with Microsoft, and in reaction to this, we saw the emerging of the free software movement. So the movement that claimed the right to have software, open source and free software. So open source means that you can see and modify the source code of a software to improve it for your specific use. And free, it means that is that no one can own it definitely, that there is that is not like a pattern or a commercial software. And of course, the Creative Commons licenses in 2001 are derivated from the free software licenses. And another big achievement is, of course, Wikipedia, the encyclopedia that that is completely under Creative Commons and open to everyone. Everyone can modify Wikipedia, can also take part in Wikipedia's governance. Regarding scientific literature, so it is also the rise of the open access movement a bit during the 90s and essentially during the year 2000. It started with we can say with the Budapest conference, but also with the Public Library of Science that you may know about under the acronym PLOS, since it became a publisher, PLOS One. And we also saw the emerging of the early open repositories and publishing platform with Archive in 1991 and some other ones mostly in the year 2000. So there is at once there is this science that is seen mostly as a motor for growth, and that science is claimed as a common good that should be protected from commercial paywalls. Eventually, open science, as you may know, became a new paradigm, since it is now admitted that the academic world is turned towards society. Most of the work in the academy is about society, about the world, especially when we talk about medicine, but especially in our times when we talk about environment, ecology, biodiversity, for instance. And the second big idea is that openness and transparency would improve science reliability, especially when we focus nowadays on more and more problems about research integrity. So openness is also so as a mean to improve the quality of science findings themselves, especially in a time where science become I would say like more a citizen issue. It's not only about developing technologies, but now it becomes a citizen issue. Excuse me, I also have to do the police. So yes, especially with ecological issues, since many people, especially big companies, are kind of not willing to make all the change that are required by ecological transition. So science become also a zone, a conflict zone, a conflicting zone. So that's why, in a sense, now society is demanding more than communicating science, more than having the knowledge of science. That is the first goal of open science, but also to be more involved in making science. So this part is where, when we talk about citizen science are not completely new. They are citizen science initiative since at least the 1980s, especially in the fields of ecology and biodiversity. It became easier with the internet, since to explain it quickly, in citizen science, people help scientists to collect data, especially when it is difficult for scientists to get all the data they need. So you understand why we did it in ecology, or the study of biodiversity, or also in astronomy, and sometimes in medicine with self-report practices. So it started like that. In citizen science, non-professional scientists, so people who are not scientists, collect data according to a protocol defined by the research team. They collect data to provide the research team. So you understand why it became easier with the internet. So there is at once there is a demand for more communication about science. There are many initiatives around popularization, like my thesis in 180 seconds, that is very popular. But there are also a demand to be involved in making science, and not only as a public. So this, as I told you, citizen science is mostly about data collection, but there are also some projects in which citizens, in the quality of sometimes inhabitants of a region or people concerned by a disease or some other cases, they also contribute to define the research question, and they may also contribute to the analysis of the data. So in France, we have this. We have a big platform that is called Science Ensemble, or Science Together, that allow you to see many citizen science projects, and also to contribute through the platform. So as I told you, the internet made it easier for everyone to contribute. Even for a few minutes, sometimes, to a project, to a research project. So if we go a bit further, we can say that with citizen science, open science prepares like the next step of democracy, where the making of knowledge itself can be shared with trained citizen. I also think about citizen convention, where non-professional citizens are trained about the topic they need to discuss. Generally, it's about environment or health. They are trained about this topic, and they eventually make a recommendation for the government about this topic. So maybe open science has a role to play in the making of this next step of democracy. And Kristell, this is your time.
Yeah, thank you, Sébastien. Yeah,
you're welcome.
Okay, as we just saw, we are surrounded by research and innovation technologies. A researcher working on his field is allowed to wonder if his research makes an impact and what is impacted by his research. Maybe it's academics, or culture, economy, health, politics and social environment. If you can change. It would be also interesting to wonder how to generate impact and how to measure this impact. The diagram you can see shows the different steps from discovery to action, and importantly, the relationship between knowledge and information in this process. And as you can see, it's really there's a lot of steps to attempt the evaluation. And how assessing the impact of research? We are using Bibliometrics. Research assessment and policy are achieved by evaluation of the scientific performance of research group, departments, and institutions through evaluation of research proposal, allocation of research funding, university rankings such as the Shanghai, the Leiden, or the academic ranking of world universities. Bibliometric is the use of statistical method to analyze publication. It is used to explore the impact of science field of a set of researchers of a particular paper, or to identify particularly impactful papers within a scientific field of research. metrics have been set up to make research evaluation more objective. And we are going to see it's quite controversial now. Bibliometrics indicators are more and more applied by governments and other funding organizations, mainly because of their large-scale applicability, lower costs, and time, as well as their perceived objectivity. The goal is to optimize research allocations and make funding more efficient and effective. And to do so, there are several bibliometric indicators that we are going to have an overview.
Excuse me, Kristell, I'm going to let you share your screen maybe.
Yeah, okay.
It will be more convenient for you.
Yeah, sure. Thank you. So indicators can focus on authors and institutions, like the publication counts, the citation counts, or the H index. They also can focus on journals, with the famous journal impact factor, or another new one, the top factor, who scores the transparency and openness of the processes of the journal. They also can focus on articles, citation counts, the number of times an article has been cited. They can focus on subjects, like highly cited papers, which are within the top 1% of papers in an academic field, or the hot papers, who are at the top 0.1% of papers in an academic field. I call them the VIPs. Bibliometric indicators, some are very well known. I'm sure you all heard about the H index. Introduced by Hirsch in 2005, the H index measures producibility and citation-based performance simultaneously. It is determined by a calculation of the number of articles that have been cited each time. But just be aware that there's a lack of clear concept. It's a bit confused the way it is calculated. It's not available to assess early career researchers. There's a lack of field normalization. And you can find different H index according to the database you're based on. It is based on. Another one is the journal impact factor, which is the average number of citations per published paper averaged over 2 years. It was introduced as the measure of journal impact but it's quite complicated. The impact factor can also be influenced by many factors. Extension of the impact factor to the assessment of journal quality or individual authors is inappropriate. Extension of the impact factor to a cross-discipline journal comparison is also inappropriate. And those who choose to use the impact factor as a comparative tool should be aware of the nature and premise of its derivation and also of its inherent flaws. That's why some new indicators are created just to have more objectivity. And it's the case of the top factor, which were launched in February 2020. It's a quite recent one by the US Center for Open Science. The top factor is described by its author as a step toward evaluating journals based on their quality of process and implementation of scholarly values. This alternative to the journal impact factor may reduce the dysfunctional incentives of journals by publishing exciting results, whatever their credibility. Top Fighter is based on the transparency and openness production, and is not a single number to rank journals. It's a modular set of indicators of journal policies to facilitate the visibility of good research practices. Let me now tell you about the uses of bibliometrics. One of these one is rankings. Whoever heard about the Shanghai, the QS, or the CW, the Leiden? Academic ranking is a set of criteria by which the performance of a university or educational institution is compared with another institution. Each ranking has its own methodology and indicators. For example, the Leiden takes into account open access journal publications. Bibliometrics, although ranking brand the institution, there are tools to improve organization and management, help take important decisions, and influence partnerships and collaborations. Bibliometrics indicators are nowadays really controversial, especially when assessing young scientists. How evaluating a young researcher who has a short career? The difficulty with assessing young research is well known. They produce few publications, and it's quite questionable to assess young scientists. And what about comparing journals? How dealing with interdisciplinarity? Another questioning concerns human and social sciences with the time of publication, monographies versus journal articles. There's a lot of question about assessing sciences. Let me now show you an example of a bibliometric analysis of scientific subjects everybody heard about, renewable energy. All over the world, the study of renewable energy draws interest in various scientific schools, economics, and especially stakeholders who can benefit from the use of renewable energy. In 2021, the EU spent $2.5 billion in renewable energy science and research and development. And science is, and in France, the budget is around $2 billion US. So here is an example of a bibliometric analysis. In this open science article, the authors aim to analyze existing research of renewable energy to identify the most influential publications, authors, organization patterns of development research area. Ash et Pyle, the authors, analyze the dynamics of publication, clusters of collaboration, and main topics based on more than 10,000 publications. They produced indicators such as the number of publications by years, by country, or by research institution, the most popular areas of research, collaboration network, most influential actors, and key concepts. Published in January 2019, it has been cited 61 times. And it is available in HAL, the French open access repository. So it's an example of a bibliometric analysis and of open science publication. as you can see, opening research opening research lets opportunities to gain recognition and resources. It's a way to preserve and make content accessible. It's a way to have a new special funding or institutional supports to gain more citation, more projects and collaborators, and more media coverage. It's a really good way to impact and gives opportunities. And Peter Sever said it very well in his book Open Access. He said, open access increases the world's visibility, retrievability, audience, usage, and citations, which all convert to career building. For publishing scholars, it would be a bargain even if it were costly, difficult, and time-consuming. But it's not time-consuming, it's not difficult. I propose you some readings if you're interested in the subject. And I've finished my presentation. I can stop sharing my screen. Sébastien, if you want to have the end.
So do you have points you want to discuss?
I think it would be interesting to have your point of view according to assessing research and how you can see the impact of your research.
I have one question for you, Kristell.
Yes.
What is the daily life of a bibliometer, and what do you do during your day?
My day starts as I think as everybody. I read my emails. And most of the time I just have to check publication on the databases, and for the new ones, and to analyze them and to know to answer about indication and about science and open science. Here in Sorbonne University, my job is related to open science and how to evaluate the policy of the university through the publication and open access publications.
Thank you.
There's a question in the chat. Okay, let me show you read the question. Is there a way to include something a bit vague like mentoring in this bibliometric evaluation? Labs, teams include also technician. Oh yeah, it's possible to analyze the authors, and so through publication we can see authors, we can see and so evaluate the authors and collaboration between the authors. And it can, but I can't see what is the function of the author.